This video introduces one of the key functions of 2D target object recognition, namely error-proofing check, and demonstrates how to configure relevant parameters using the 2D target object recognition tool. Error-proofing check uses 2D camera images to identify target objects and verify whether they meet specifications. It can be applied to binary classification, deformation classification, misalignment and tilt classification, and quantity counting. Next, we will take the front-back inspection of a condenser as an example. When the front and back sides of the condenser are hard to distinguish in the point cloud, AI acquires distinguishing details from the 2D image, so that the robot can sort and place the target objects based on their orientation. In this scenario, the overall recognition process includes image preprocessing, pose correction, error-proofing check, and general settings. During image preprocessing, color space conversion is used to adjust color and brightness. To improve subsequent recognition results, enhancement and denoising operations can also be applied to enhance the object features. After image preprocessing, perform pose correction. To ensure accurate recognition, first set the region of interest, ROI. Then, select an appropriate correction method to align the current image with the template. In this case, error-proofing check uses Quick AI training model to inspect and classify target objects. General settings let you configure output ports to send the judgment results and status information to the robot for sorting and placement. Now let's move on to the configuration. Open Mech-Vision and enter the 2D target object recognition project. If image distortion exists, please perform distortion calibration first. Ensure that the camera acquires images normally and that the image quality meets the requirements. Once you confirm there is no distortion, configure the 2D object recognition step. Click Config Wizard to enter the tool interface. Then select Error-Proofing Check and choose Binary Classification. Click OK to proceed to image preprocessing. In this case, the brightness on both sides of the condenser is relatively low. To improve the contrast between the target object and the background and highlight the profile, image enhancement can be applied. Open Image Preprocessing. Click Preprocessing Method. Click Contrast Enhancement. Then, choose Sharpening as the enhancement method and turn up the sharpening strength. After setting, click Run Step to check the preprocessing effect. You will see that the object surface becomes lighter, but gray noises appear on the left and right sides. To address this, further enlarge the X direction and Y direction window size to soften the sharpening effect and thereby reduce noise. Click Run Step again to check the preprocessing result. If the object surface is bright and clean with clear profile and no obvious noise, and you can proceed with the subsequent steps. Click Next to proceed to pose correction. To eliminate angular deviations and avoid misclassification, perform correction. Common correction methods include no correction, 2D alignment, and 2D blob alignment. When you use the no correction method, the system directly recognizes the original input image with no pose alignment. This is suitable when the object positions are fixed in the image, and high alignment accuracy is not required. The 2D alignment method aligns the input image to the template via translation and rotation. It's suitable for objects with varying positions and distinct profile features, where the object profile matches the template. If the object doesn't match the template, use 2D blob alignment. The 2D blob alignment method detects light and dark region, namely blobs. This method filters the target blob by geometric constraints, and computes its minimum rotated bounding rectangle. Then, it adjusts the pose to align the blob centroid with the image center, and orients the principal axis of its rotated bounding rectangle parallel to the image axis. It's suitable for objects with clear profile and large, continuous light and dark region. Here, the condenser's profile is consistent while its position varies, so 2D alignment is applied. Click 2D alignment and name the parameter group. Next, select the recognition region. Because the condenser's position varies, it's recommended to select all as target region as ROI to ensure all parts are covered. In Select Template, click Edit to open the 2D template matching editor. Here, the image is automatically captured, and you can name the template. Next, draw the template based on the object profile. In this case, the condenser has clear profile features, and the surface holes don't interfere with template alignment. So you can draw the template directly. If the object's surface texture interfere with alignment, use the eraser tool to mask the surface first. Then proceed to draw the template. Due to the irregular shape of the condenser, select the polygon ROI to outline the region. Enlarge the drawing range slightly beyond the actual profile to ensure all edges are included, then right-click to finish. After selection, the object center point has been generated automatically. Generally, the default settings are appropriate. If needed, adjust the center point through Edit Center Point. Then, click Generate Template to review edge feature extraction, and adjust the relevant feature parameters accordingly based on the image visualization. In the current view, the condenser surface is densely covered with yellow and green marker dots, including some interfering points that are not part of the desired profile edges. To prevent noise from affecting matching, increase the coarse edge threshold and fine edge threshold to retain the profile feature. In this case, due to unfixed object positions, set the angle search range to -180 degrees to 180 degrees for full angle matching. If the camera height or position deviates slightly, the apparent size of the object may change. To improve accuracy, adjust the scale ratio accordingly to allow minor scaling during matching. After completion, generate and save the template. When satisfied, simply save the template. Click Update to apply the latest template configuration. Select the template in the drop-down list. Additionally, because the template was created from the condenser's front side, lower the minimum match score appropriately so that the matching results can cover both the front and back faces. Click Run Step to view the template matching results in the visualization region. To test the matching on both sides, you can click Run Project, and further confirm the effectiveness based on confidence. In the visualization area, green indicates successfully aligned edges, while red represents misaligned ones. In this scenario, the green edges serve as the primary basis for evaluating alignment quality. Therefore, even though the object on the reverse side exhibits numerous unaligned red edges, the overall profile still matches the template, ensuring a successful alignment. Please proceed by clicking Run Project. The condenser matches well, so no further parameter adjustment is necessary. Click Next. With pose alignment completed, proceed to error-proofing check to classify the condenser's two sides. In this step, based on the aligned image, you will quickly train an AI model for accurate recognition. Please operate as follows. Under Set ROI, click Edit and select the valid target region. Since the pose correction has already been completed, the target region can be appropriately narrowed down. Under Label Images, click Edit. In the Label class on the right, click Label Images for both OK and NG categories to provide training samples for AI. Please note that each category should contain one labeled image respectively to improve the accuracy of front-back detection. Here the back side has been labeled. Next, place the front side up. Then, click Acquire Images to get new images and continue labeling until each category has one labeled image respectively. Click Train, the software will train the model using the labeled images. To check whether results meet expectations, click Validate to open the validation interface. If the training results are incorrect, try to adjust the confidence threshold. Moreover, you can use the heat map. The highlighted region is the key region where AI mainly focuses. You can check whether AI is influenced by other objects. In this case, the default threshold suffices. Once the front and back sides recognition is reliable, click Next to open General Settings. Here you can configure output ports for the binary recognition results. Click to add output ports if needed. In this scenario, classification judgment result is output by default. If you want to view the classification status, classification confidence, and image with result, select the corresponding ports. Now, this completes the configuration for front-back inspection. Next, connect the output step to view the overall execution results. In this case, it only outputs classification judgment results, so you can select Custom in the output type and name the port. Then, connect the corresponding step port and click Run. The results can be sent to the robot for subsequent sorting and placement based on the two sides of objects. For more information on 2D target object recognition applications, please watch the other tutorial videos and refer to related documentation.